The indeterminate case refers to a situation in mathematics where it is difficult to determine the limit of a function directly, typically when you encounter the form 0 over 0 or infinity over infinity. It often occurs when you try to find the limit of a function as it approaches a particular point, and you can't obtain a clear answer. L'Hopital's rule is a calculus technique used to find limits, especially in indeterminate cases, where the limit may have the form 0 over 0 or infinity over infinity. This rule is typically applied when you have two functions, fx and gx, that are both continuous at a point, and both functions approach 0 or infinity at that point. L'Hopital's rule states that if these conditions are met, the limit of fx over gx as x approaches c is equal to the limit of f prime x over g prime x as x approaches c. Let's examine a few examples of limit problems. First, 0 over 0 form. Find the limit as x approaches 1 for ln x over x minus 1. As x approaches 1, ln x approaches 0, and x minus 1 also approaches 0, so we can apply L'Hopital's rule. After taking the derivatives of both the numerator and denominator, the fraction can be written as 1 over x over 1. In simpler terms, it becomes 1 over x. Therefore, the limit is 1. Second, infinity over infinity form. Find the limit as x approaches infinity for e power of x over x squared. As x approaches infinity, both e power of x and x squared tend to infinity, resulting in an infinity over infinity indeterminate case. By applying L'Hopital's rule and taking derivatives of both the numerator and denominator, the fraction can be written as a power of x over 2 gal x. Since it's in the infinity over infinity form, applying L'Hopital's rule once more, we can conclude that the limit is infinity. Third, 0 times infinity form. Find the limit as x approaches 0 from the right for x times ln x. As x approaches 0 from the right, x tends to 0, and ln x tends to negative infinity, creating an indeterminate case. Rewrite the expression as ln x over 1 over x, and it becomes infinite over infinity. Apply L'Hopital's rule. After simplifying the fraction, the limit becomes 0. Fourth, infinity minus infinity form. Find the left-hand limit as x approaches pi over 2 for secant x minus tangent x. As x approaches pi over 2 from the left, both secant x and tangent x tend to positive infinity. Rewrite secant x as 1 over cosine x and tangent x as sine x over cosine x. The limit becomes 0 over 0 as x approaches pi over 2 from the left. Apply L'Hopital's rule. After differentiating both the numerator and denominator, the limit is 0. Fifth, 0 power of 0 form. Find the limit as x approaches 0 from the right for x power of x. Rewrite the function as e to the power of len sauce to the power of x, which becomes e to the power of x ln x. As x approaches 0 from the right, the limit of e to the power of x ln x is 0, as shown in example 3. Therefore, the limit is e to the power of 0, which is 1. These examples illustrate how to apply L'Hopital's rule to evaluate limits in various indeterminate forms. See you next time!